Okay, so we're going to start with polars, though. And there's always a guarantee you're going to have that on the test, because anything that's in the BC syllabus, it will be on the test. Whether it's free response or multiple choice, I never know. So, you want me to derive the formula? How will you get the area? Well, if you're looking at a polar curve, and these are the basic things you have to know. There's your radius, and this is the x distance, and this is the y distance, and that's theta. So if you look at the cosine of theta, that's x over r. So x is equal to r times the cosine of theta. So if they ask for dx dt, you are going to have to take the derivative of this, and both r and theta are changing. You also have to know how to graph points. Sine of theta is equal to y over r. So y is equal to r sine theta. And if you do x squared plus y squared, that's going to be equal to r cosine squared, r squared cosine squared of theta, plus r squared sine squared of theta. And if I factor out r squared, we have a trig identity. And that's just what? This is the one you have to know. 1. So we get the equation of a circle. X squared plus y squared equals r squared. So if I want to get the angle, for instance, I have to be able to convert back and forth between these coordinates. And so the tangent of my angle is equal to y over x. So if you want to find the angle, it's the inverse tangent of y over x. So those are the big things you have to know about this. And then the area of a sector, or of a polar region. So what I'm going to do is take this little sector, and this is the change in the angle. So that's delta theta. And if you remember, and this would be like a radius, that in a sector, the area is equal to theta out of 360. This is in case you forget. Pi r squared, because we all know that, right? It's what part of the circle we have, times the area of the circle. Well, there's 2 pi radians in 360 degrees. And that's pi r squared. The pi's go. And so the area is 1/2 r squared times theta. Well, in this case, if it's the change in the area, if you're talking about a little sector, it's equal to 1/2 r squared d theta. And that's your formula. So all you have to do is integrate it. And so the area is equal to 1/2 r squared, r squared d theta, from theta 1 to theta 2.
The tricky part is just finding what those...
The angles are. That's what I find that the tricky part. So we could either start with multiple choice or free response, but that's basically all you need to know. The only other thing you need to know is how to graph a point, and that's r theta. So if r is 1 and theta is pi over 2, and this to me is not intuitive. I'm going to go 90 degrees from my beginning ray, and I'm going to go 1 unit up. If I wanted negative 1 pi over 2, then I would do 90 degrees, but because it's negative, I'm going to actually go down this way, 1. So that's where that point is. You remember that? So when you get some of these polar curves, you're going to have to figure out the angles, and you have to know how to graph those points, otherwise you're in trouble. So if I had the ordered pair 1 and pi, I'm sorry, negative 1, 1 and pi, then I would go pi, and then I would be right here. But if I had negative 1 and 0, then I would be doing no angle, but I'm going to go negative 1, so I'm going to go over here. Because the negative goes the opposite direction. If it were positive 1, 0, it would be right here.
It goes the opposite direction.
The negative makes it go, you go the angle and then go the other way from the origin. Okay, well, let's do some problems. I'll have to find some. Uh-oh. I forgot. I didn't fix that. So I'm trying to think of one of the last. Well, let's look at some B problems. beaches and water. Okay, so I want the area for S, but I have to figure out the angle. That's where the problem is. And that's why you have to know how to graph these. Although you guys are probably more clever than I was about this. So it's going to be 1/2 r squared, and r is 1 minus 2 cosine of theta squared d theta, and now I have to figure out my angles. So I need to know what angle this is and what angle that is. So if theta is equal to 0, because I'm going to start at 0, then r is equal to 1 minus 2 times the cosine of 0. So what's r equal to? -1. So that's this point right there. This is -1, theta being 0. Glad it's you guys, not me. It kills my arm. I think it's 0. And then we want to, so we're going to start out with angle of theta be 0. We're going to start here, and we're going to sweep this out. Question is, where is that? So let's try theta equal to pi over, well, let's try pi. I don't think that's it. No, this is pi. When theta is pi, r is equal to 1 minus 2 cosine of pi. You guys, what's the cosine of pi?
The cosine of pi is
No, draw the picture. There's pi. It's -1. So this ends up being 3. So this angle here is pi, and it's a +3, so I'm right there. So have a good guess where that is? When theta is 0, we're going to start this little point right here. When theta is pi, because that's what my interval is, then my radius is 3, so I'm over here. So what angle do you think that one is? Pi over 2. Let's try that. So r is equal to 1 minus 2 times the cosine of pi over 2. Yeah, you can't be late. So what is r then? What's the cosine of pi over 2? 0. Well, cosine of pi over 2 is 0. So r equals 1. So that's this point right there. I need to get 0 here, don't I? Either I can do guess and check, or I can say 0 is equal to 1 minus 2 times the cosine of theta. And I know my cosine of sine pretty well. I probably could guess it, but 2 cosine theta is equal to 0, not 0, 1. So the cosine of theta is equal to 1/2. And if you don't know that, then we draw your little triangle. There's 1, there's 2, there's square root of 3. How many degrees is this? This is the square root of 3. So this is 30, and this is 60, or pi over 3. This is going to be 2 points. I believe I'm going to get a point for this, and then a point for the r squared d theta. Let's find out. I have to move some things around, though. And there it is. So I did that right. Did you see how I figured it out? I could have figured it out also on this one, finding that was 0. I could have said 0 equal to 1 minus 2 cosine of theta. So 2 cosine theta is equal to 1. Cosine of theta is 1/2. No, that doesn't work. Oh, it's not 0. It's -1, sorry. So that 2 cosine theta is equal to -2. So the cosine of theta, sorry, not -2, but +2. So cosine of theta is equal to 1, so theta would have to be equal to 0. I just did guess and check. Unfortunately, guess and check wasn't going to work for that point, not as easily. Now the next part, so that was 2 points. The next part is really important, but it's not hard. if you know those formulas I just gave you. Because if you know that y equals r sine theta, x is equal to r cosine theta, that's what you're going to differentiate. So I think you guys should do this. So x, this is b, x equals r cosine theta. Let's substitute in r. So x is equal to 1 minus 2 cosine theta, cosine theta. I wouldn't distribute it, I would just use the product rule and be done with it. Because you don't have to simplify it. And y is equal to r sine theta, although it's easy to differentiate that, a little easier. And so y is equal to 1 minus 2 cosine theta sine theta. And I believe you get your points for making that statement. So that's not bad, but you have to remember, I don't have any tools. You have to remember these pieces right here. Because I want to just differentiate r, but that's not right, unfortunately. Where is it? See, you get a point just for using those. And then you get a point for your derivative. So you guys could find the derivatives, because it's the product rule. It'll give you a chance to do that. Write an equation in terms of x and y for the line tangent to the graph of the polar curve at theta equals pi over 2. Well, we figured out where that was by accident, remember? This was pi over 2. Theta equals pi over 2.
So if you put that into the,
Well, we have to write the equation of the tangent line, right?
yeah, but Q plus, so we found the, or no. the-
Well, I start with writing down what the equation of the tangent line is. Was it C? So y minus y1 equals m, x minus x1. So you can find out what x and y are, because x is equal to r cosine theta, y is equal to r sine theta. So you can find the x and y, and you remember how to find the slope. It's dy dx. It's just like parametrics, just like vectors. It's dy d theta over dx d theta. And you just have to evaluate all that at pi over 2. Were we given that, or did we figure that out? We must have figured it out. Because if x is r cosine theta at pi over 2, the cosine is 0, right? Theta is equal to pi over 2, so x is equal to 0. And at pi over 2, y is equal to r. And what was r? R was 1 minus 2 cosine theta. So r is equal to 1. So y is equal to 1. And all I have to do then is evaluate my two derivatives at theta is equal to pi over 2. And I already did those derivatives. Now, if you have something that's a little bit different than this, but you made a little mistake, like a sign error, I believe we'll do a follow-through error and give you the points for that. But if you make it way easy, no, they won't give you the point for that. And there it is. You should get -2. So you get a point for x and y, a point for your slope, and a point for the equation of the tangent line. That wasn't that bad, was it? No. Do you want to try another polar?
Yeah, the two ones that we have.
Yeah, we'll have to go back to like 2004, I think. Or maybe not. Maybe it's 7. Okay, so this is dr d theta. Or r is theta plus sine of 2 theta. Find the area bounded by the curve and the x-axis. So what I do is I look for my angles, and it says my angle's between 0 and pi. And this looks like pi there, doesn't it? It's at -3, a little bit left of that.
Oh,
So I can say pi equals theta plus the sine of 2 theta. And you can't do, now this is a graphing calculator problem, so you could read it off your graphing calculator as well. So the only theta that makes sense here is pi. But just by guess and check. You cannot solve that unless you do it graphically.
so it's just because those are that's the domain.
Well, it's not always at the pi, though, as you saw in that other problem.
Yeah.
So you have to check it. And what about 0? This is starting at 0, so 0 is equal to theta plus the sine of 2 theta. Well, just guess and check. Theta is 0. That makes that true. So there's nothing wrong with it. So it's 1/2, and I actually have it here. It's 1/2 r squared d theta. Sorry. So it's 1/2. It always does that. It's 1/2. And we're going to go from 0 to pi, because we talked about that. And r squared, what was r? No. Theta plus the sine of 2 theta. D theta. And it's a calculator problem, so you'd have to use your calculator to find that. Always 3 decimal places. They're going to give us 3 points for this problem? They are going to give us 3 points for this problem. 1 point for this, for the r squared d theta, and we can all do that because that's not bad. And then 1 point, you know you have to have a half in there, and then, you might not get the angles. Now, if you did this to pi over 2, this number would be wrong, but I don't know if they would give that to you or not. When in doubt, use the domain if they give it to you. That's what I would do. I can do it that way, or there's another way I can do it, because it tells me that my x-coordinate is -2. And we remember, this is for part B, that x equals r cosine theta. So -2 is equal to my r, which is theta plus the sine of 2 theta times the cosine of theta. This is a graphing calculator problem. You do not have to be in polar mode. You can just solve on your graphing calculator x plus the sine of 2x cosine of x. And personally, my preference is to make this equal to 0. I would not distribute it. I would type it in as I'm writing it, because if you distribute wrong, you're going to get the wrong answer. And so it's a graphing calculator. Just make sure you are in radian mode. I don't know the y-coordinate. Otherwise, I could have done it that way.
But then if you found x,
Then I could find the y-coordinate once I know theta.
yeah.
They didn't ask us that, did they?
Oh, no.
No. So,
Yeah, they thought.
no, they don't ask us for y. Yeah, this asks for the angle. So because I know the radius and all of this is like this, I can do that. I don't need to have the y. They could have then asked for the y. They would lead you right through like this. Okay, and how many points is that? I'm going to guess 2. There it is. 1 for that, 1 for the answer. So even if I can't use my calculator correctly, I still think you can get a 5 without a calculator. There's so much less emphasis on the calculator now. But just make sure you are in radian mode. And then, for theta between pi over 3 and 2 pi over 3, the r d theta is negative. R is a positive value. Is R positive? I believe it's positive. Looks like it's going towards the origin. Let's check that. R is decreasing as interval. Means that the curve is getting closer to the origin. Yeah.
So for this one, you don't have to say the r is positive like you did on the other one.
Well, I'm debating whether it is positive. I know it's positive between 0 and 90 degrees. Oh, wait, I have to think about it. The cosine becomes negative in the second quadrant. However, this is going to be, oh, wait, it's r. Oh, sine's positive. Yeah, r is always positive.
Yeah.
I was looking down here at dr d theta. So dr d theta is negative, but the r is positive. Yeah, it's just moving towards the origin. I don't think they're going to trick you. They didn't seem to say that on this. Although not everything that they put in the rubrics, it's not always complete. Like when you do L'Hopital's rule, you have to say your limit was 0 over 0, and that's not in the rubric. which I didn't think was fair because I know my students probably did not say 0 over 0, but they recognized it. But the way you have to think of it is you have to convince the reader that you know that you can use L'Hopital's rule because you had 0 over 0. So that was 2 points. And it says find the value of theta that corresponds to the point on the curve in the first quadrant. So we're just over here with the greatest distance from the origin. And they gave us the derivative, which was very nice, because this is a maximum. This is the max-min existence theorem. Where are your critical points? So dr d theta equals 0, and don't forget the endpoints. And then you evaluate r of theta at your critical points. Sorry, I have an extra dot in there. So I like to do mine in tabular form because that's just what I'm used to doing. So this is theta, and this is r, and so this would be at 0, pi over 2, and my guess is going to be the derivative, and where the derivative is 0. And it's a calculator problem. So what's the derivative? 1 plus 2 cosine 2 theta. So 2 cosine of 2 theta, you would use a calculator. I'm challenged by this. It's equal to -1. So the cosine of 2 theta is equal to -1/2. And we're between, well, I'm going to be between 0 and pi over 2, but this is going to end up being, where is my cosine -1/2? If you look at the graph, you can look at it 2 ways. You can look at it this way. That's pi over 2. And so -1/2 is down here. Or I can look at it on the unit circle. So that'll be in the second quadrant. So that I want to find an angle whose cosine is -1/2. So this is a -1, this is a 2. How many degrees is that? This is 60. Right. So this is 120, and 120 is 2 pi over 3. Or you could do it, that's the way I used to do it. If this is pi over 3, measured that way, then this is pi over 3 and another pi over 3. So theta is equal to pi. So this angle here, 2 theta is going to equal pi over 3. So what's theta equal to? Pi over. Remember, this is just an angle, 6. And then you would evaluate r. And what was r? I forgot. Theta plus the sine of 2 theta. And so r of 0 is equal to 0 plus the sine of 0. This guarantees both a max and min. R of pi over 2, I like to do the endpoints because they're usually nice, is pi over 2 plus the sine of pi over, plus the sine of 2 times pi over 2. Sine of pi, so that's just pi over 2. And again, you could just use your calculator, but to me it's faster just to do it. Pi over 6 is pi over 6 plus the sine of pi over 3, because I have to double that. And the sine of pi over 3 is the sine of 60 degrees, which is the square root of 3 over 2. I'm not for sure if I use my calculator, because what are we asking for? Furthest away? Yeah, furthest away, I'm going to guess it's that one, but I always guess wrong. This is 1.57. Pi over 6, that's about a half. I don't know. I use my calculator just to be sure. I'm going to guess it's the derivative. Do I have the right angle? See, they were pretty close. So you get 1 point for finding out theta's pi over 3. Did I get pi over 3? Wait, I thought I had pi over 6. Did I mess up? I have pi over 6. Why? Well, you can do it on your calculator. Oh no, this is... I don't know. I have to solve that. I did that wrong. But I would check it with my calculator. So this should be pi over 3. Oh, because I didn't show my work. I always do the reference angles. Cosine is 1/2. That's 1, that's 2, so that's pi over 3. Well, I guess I'm going to have to use my calculator and see what I did wrong. Or else I copied it wrong, I'm not sure.